I'm Professor Rad, and this is Precalc video 1-4, reflection transformations. So in this video, we will be continuing our conversation about transformations on functions. In the previous video, we talked about inside and outside transformations, and we have kind of a summary of what was going on there. So if we added or subtracted a value, that resulted in a shift. And if we multiplied or divided by a number, that resulted in a stretch or a shrink happening. Anything that happens outside the function, so outside the f of x component or the action, the important stuff like the squaring or absolute value or whatever, that's going to be an outside transformation. It will have a vertical impact, and it follows the order of operations and what your intuition tells you will happen. Inside transformations are horizontal transformations, and they work the opposite of what you expect. So if you have like +2 inside the function, that's not going to be a shift right, it's going to be a shift left. It's opposite of what you want it to be. In this video, we're not talking about stretching or shifting. We're going to be talking about a new type of transformation, which is a reflecting. So we have 3 reflection transformations that we'll be discussing in this video. If you would like to pause and write down these guidelines, you may do so now. Or really, I mean, you have free will, so whatever you want to, if you wanted to. But I'm nicely out of the way at the moment, so that would work. So we're going to follow the same general guidelines of outside transformations having a vertical impact and inside transformations having a horizontal impact. So that's why if I have a negative on the outside of the function, it's going to have a vertical impact. And if I have a negative on the inside of the function, it's going to have a horizontal impact. This negative, when you multiply the function by the negative, it's going to flip the function, or reflect it. So if we have a vertical reflection, that's going to be over the x-axis. So it's not the vertical axis we're reflecting over. We're changing the y values. It's a vertical reflection. So we reflect over the x-axis. And if the negative is on the inside, we're going to reflect over the y-axis. So it's a horizontal reflection. So whichever is easier for you to remember and associate with these changes is what I recommend that you write down or you highlight here. So for me, it helps me to remember it's a vertical reflection and a horizontal reflection. If it helps you to remember the axis, then you want to remember the negative on the outside is a reflection over the x-axis, and the negative on the inside is a reflection over the y-axis. So whichever way is easier for you to remember is probably the better way for you to use to remember those. Now, when we have the absolute value surrounding a function, we're not talking, I mean, we are talking about the absolute value function, but that's not the function that's being transformed, that's the transformation. So remember that the absolute value function is going to take any value and it's going to turn it into a non-negative number. So if I have the absolute value of f of x, remember f of x just means y. So I'm taking the absolute value of y. So that means we're going to have an impact only on the y values. The x's don't change. What that's going to do is it's going to take anything that's on the bottom half of your graph and reflect it up to the top half. Anything that was there already in the top stays in the top. The bottom just moves up to the top, kind of reflects up. So it's kind of like a half reflection. It's kind of like a half vertical reflection because the stuff that was positive, all the positive y values remain the same. All the negative y values now become positive. So we're going to do an example of each type of reflection in this video, and we'll be using the same base function for all of these examples. So I'm going to take a moment, erase the board, and write our base function there, and then we can get to transforming it. So for me, it'll take a moment, but for you, it should be instantaneous. The example for this video is actually a 3-in-1. So we have this beautiful function, f of x, graphed over here. Once again, if you'd like to pause the video to sketch this function, you may do so. Or you can, live your life, do what you do. What we're going to be doing is we're going to be graphing g of x, which is negative f of x, h of x, which is f of negative x, and capital F of x, which is the absolute value of lowercase f of x. So this is one thing I should mention. So mathematicians often have 2 functions that are similar or somehow related, and they like to refer to them by the same letter to indicate that relationship. So for example, here we have the capital F of x is a transformation on the lowercase f of x. So sometimes we'll be using different letters, but if I have like 3 functions I'm transforming, I don't want to have 6 letters. It's much easier just to remember 3, and then you know which ones are connected to each other. So all this means is pay attention to case of letter. So lowercase f of x is going to be different from uppercase f of x. Sorry, but that's the way of the world. So that's how we're going to have to operate. Bear in mind, if you tend to write in all caps or in lowercase caps, that you're paying attention to the case of the variables and the letters that we're using to represent functions. So for this example, let's start out with this first one, negative f of x. Now, what's nice about reflections is that we're not expanding or contracting the size of the function, and we're not, wandering the function to different places. We're just flipping it either vertically or horizontally, which means to set up your axes, once you figure out the type of reflection that's happening, then you can just flip your positive and negative axes, right? So in this case, our axes are uniform all the way around. So for each of these 3 functions, when we go to graph them, all we have to do is create the same axis. So let's do that. Let's create the first set of axes here for g of x. So we're going to 4s all around. Now for g of x equaling negative f of x, is that negative on the outside or the inside of the function? So it looks like it's on the outside. I got my little reference down here. Oh golly, I added to it. Threw all my markers off the line here. So we have a negative on the outside, which means it's a vertical reflection. So we're going to take this beautiful function and just flip it up and down. So what's nice is anything that's on the x-axis is going to remain fixed, and then all the y values, we negate them. So here we have a nice point at negative 3, 0. That's on the x-axis, so it doesn't change. Negative 2, negative 2 is now going to become negative 2, positive 2. So this flips up to the top. 0, 0 is on the x-axis, so it remains fixed. 1, 1 is going to flip down to become 1, negative 1. 2, negative 1 is going to flip up to become 2, 1. And then 3, 1 is going to flip down to become 3, negative 1. And then, as always, we're going to connect these points in the same manner in which they were connected here. So one thing I want to point out, I don't know how clear it is on my sketchy whiteboard drawing here, but this segment from 0, 0 to 1, 1 should be a straight line, and everywhere else it's curvy. So these 2 points were connected by a straight line, which means these 2 points need to be connected by a straight line, and everywhere else it's going to be curvy. So I have a curvy piece here, and then we have a curvy piece here. And it should look like I took our original function and just flipped it. For the, so I should label this, right? So this is g of x. Okay. Now for h of x, we have f of negative x. So when the negative's on the inside, that's an inside transformation, so it's a horizontal change. So it's a horizontal reflection. In other words, we're going to be reflecting over the y-axis. So just so we can kind of compare all 3 of these graphs, I'm going to try and make some room for all of them here. So let's graph h of x over here. And I'm actually going to do this transformation in a different way. So we did this first example in a visual manner where we took this and we flipped each of the points visually and we drew the graph here, which is totally fine. If you're comfortable with that, fabulous. If you're not so comfortable with that, if you were like, so then let's look at an alternate way to do this one. So for this one, we're going to kind of make like that table of values like we did for when we had multiple transformations. So I'm going to create a list of the original points and then the horizontal reflection. So our original points, we had -3, 0. We had -2, -2, 0, 0, 1, 1, 2, -1, and 3, 1. Now, when we have this horizontal reflection, we're impacting the X value. So we're going to be negating the X value. So what that means is for each of these points, the Y's will stay the same. And now we're just going to negate all the X's. So instead of -3, 0, that's going to turn into 3, 0. Instead of -2, -2, that's going to turn into 2, -2. 0, 0 stays the same. 1, 1, this will turn into a -1, 1. 2, -1, that's going to turn into a -2, -1. And 3, 1 is going to turn into -3, 1. So if I'm doing a horizontal reflection, I'm going to negate all the X's because horizontal changes the X values. Then to graph that, I can just plot these points on the graph, and we should get what would look like if I flipped this. So basically, we should end up with this big, awkward piece on the right and the skinnier, more symmetrical piece on the left. So let's see if that's what we get. So here's my 3, 0, 2, -2, 0, 0, -1, 1, -2, -1, and then -3, 1. Now I know that these two pieces close together are going to be the straight line component, and the rest of it is curvy. And that's our function h of x. Cool. So depending on what you're more comfortable with, you may feel more comfortable visualizing and going to the graph here, or you might feel more comfortable writing your original points and then saying, here's like the map that happens, here's what's going to change, and then plotting those points. Personally, I am not a very visual learner. I mean, I kind of am, but it's hard for me, like when I think of stuff, it's hard for me to picture images. I tend to think more in terms of like sounds and words and stuff. So for me, this approach was very difficult when I was learning how to do transformations. So I used to make these tables a lot. So if you have to make the tables, that just means you're more grounded in algebra than you are in your graph. And that's okay, because we're working up skills to build stronger connections between those. So you go where your strength is. If your strength is in creating a table of points, do that, and then you can create your graph. If your strength is visualizing what's happening, use that. So visualize what's happening here and use that to create your new graph. So hopefully that helps a little bit, you know, which technique's going to work best for you. I'm probably going to use, I don't know. We'll see how I feel after I draw the grid, I guess. So for the third one, we've got capital F of X. So let's create our grid space for that. It's going to be the same as usual. I don't want it to run into stuff though. Again, I apologize if you hear the squeakiness of the marker. It just wants to be heard today. Okay, so why don't we do, let's do the visualization and then we'll do the table and compare. We'll see if we would have gotten the same thing if we did the table. So we're going to do the absolute value of f of x. What that does is it just reflects your negative y values. So what I like to do to start this out is I like to graph what stays the same. So that means anything above the x-axis. So this little piece here. So that's the component of my original function that's above the x-axis. That stays the same. So I'm going to graph that piece first. Now this is a little bit tricky because we don't cross the x-axis here in nice points. We do cross at 0, 0, but then we're kind of like a little bit closer to 1 and a little bit closer to 3. So I have my 0, 0, a little bit closer to 1 and a little bit closer to 3. And then we have 3, 1 and 1, 1. Got a curve here. Then we have the straight line segment there. So when we're graphing the absolute value of a function, we want to make sure that, I just got to notice that my battery's dying. So I'm going to run off screen for a second. I don't know where it was. So when we go to graph the absolute value of a function, I like to start by taking whatever was above the x-axis and graphing those, because those are all the positive y values. They don't change. What does change is everything that was below. So we're going to take this piece here, for instance, and reflect it up. So this point 2, negative 1 is now going to become 2, 1. And we flipped it up. So what was a u now becomes like this n, like a little hill. Similarly, these 2 points are going to change. Well, this one stays the same because it's on the x-axis. But this point here that was at negative 2, negative 2 is going to reflect up to become negative 2, positive 2. And then we are going to, so that's a little, and then we connect those kind of like we did here, right? So actually, if I look at this function, this weird looking thing, there should be nothing below the ground. Okay, so nothing below the x-axis. Notice what I drew in purple here matches those components up here. And what's in red matches the original function. So this is capital F of x. So this is the absolute value of lowercase f of x. Now, if I wanted to do this by creating a table of points, I could do that. And if you feel more comfortable with that one, absolutely go that route. The absolute value of a function is definitely the weirdo of this grouping here. And this is the one students ask me a lot about, like, how do I do that again? So here's how we can do this with our table. So we're going to have the original, and then we're going to have the absolute value of it. So I'm just going to copy down my original good points. So we have negative 3, 0, negative 2, negative 2, 0, 0, 1, 1. And then we have 2, negative 1. And then we had 3, 1. So those were our nice points that we had on our original graph. So to graph the absolute value of that function, we're going to, because the absolute value is on the outside of the function, it impacts the y value, right? Outside is a vertical change, it changes y. So that means we're going to take the absolute value of all these y values. So we end up with negative 3, 0, negative 2, and this negative 2 turns into positive. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of negative 1 is 1. And the absolute value of positive 1 is still positive 1. So if I look at what that would give me in terms of my graph, I'm going to be very sketchy here. I have negative 3, 0, negative 2, 2, 0, 0, 1, 1, 2, 1, and 3, 1. So notice how if I only plot those nice key points for the absolute value function, I get something that's kind of hard to interpret. So the reason it's hard to interpret is because of these 3 points on the same line. I don't want to connect them with a horizontal line because in my original function, there was no horizontal line. So if I reflect it, I won't be getting a horizontal line if I didn't have one to start with. So this is where these other points are going to be helpful. If I know that the x-intercepts don't change because the y value remains 0, that's going to help me find some more points to figure out the shape of this function. So I had a little bit after 1, and then I had a little bit before 3. So it doesn't help tremendously, but if I take my time from here, these appear to be following the same shape, right? So same kind of shape right there. Then from here, no weirdness, that's kind of the same. And then I guess I'm just going to follow the same shape there. And then I have, here's my U from one intercept to the next. It was kind of like a U. So I want to connect from one intercept to the next, like a reflected U. And now from here to here, it's going to be the same. So from here to here, it's going to be the same. So you can see if we used our table of values here, we got some nice key points, but that wasn't enough. We also needed to get the x-intercepts to help us figure out where this like flipping is going to happen. And we need to take our time, take it slow, and kind of follow along. Here we had a curve, so here we had the curve, right? And kind of go from point to point. So you do need to know where these reference points are with regards to the original graph. But as you can see on my sketchy sketch here, we ended up with the same graph as when we just did them kind of more visually. So that's going to be it for this video on reflections. In our next video, we're going to wrap up transformations by combining all the things. So I'm going to keep this list here so I don't have to rewrite it. But we will be talking about shifting and stretching or shrinking and reflecting all in combination with horizontal and vertical changes. So it's all going to be happening at once. So hopefully this video helped you out with some reflections, and I look forward to seeing you in the next one. Bye for now.